I'm going to talk about Kubernetes and user interfaces. Really briefly, I'm Gareth Rushgrove. I'm Gareth R. I live in Cambridge. You can find me on the internet pretty much everywhere by that if you want to talk to me afterwards or complain or talk about this talk. I work for Puppet Labs. I've got some Puppet bits and pieces in the talk, but it's sort of a broader ecosystem thing. If people want to talk about Puppet, come see me afterwards. I'm mainly talking about, I guess, user interfaces and how that plays, I think, into Kubernetes, where Kubernetes is strong, where other things as part of the ecosystem play. I'll introduce some sort of concepts, different types, different paradigms for user interfaces. I'll have some demos, because it's KubeCon, and we've got to have live demos. And I want to talk at the end more about big picture sort of ecosystem stuff. A lot of that actually came up in the keynote and came up in the State of the Union, and I'm going to dig into some of the details. So I felt like that set me up quite well, hopefully. So if I fly through parts of it quickly, it's because it was in the keynote. If you weren't in the keynote, sorry. Hopefully we'll have time for questions at the end. So, what do we mean by users and what do we mean by interfaces? Because what I want to get at is that there isn't one answer. There isn't probably one way of doing things. And there are many things that will be done by different people once we get Kubernetes past the sort of like, I've downloaded it and I've run it and wow, this is cool for running my applications. How do I convince my organization to run that? Your organization might be 10 people. Who works in an organization less than 10 people? Who works in an organization less than 100 people? Who works in an organization less than 1,000? 10,000? 100,000? Different people in different sizes of organizations are in different contexts. Rolling any piece of software out is different. How it will be interacted with is different. That might be... There's lots of different angles to this. That might be you're primarily creating new content. You're pushing things into Kubernetes. Or it might be that you're consuming it, either as someone further down that sort of the development or operations chain, or just as a user. You might be a developer or you might be an operator. Yes, we're talking about people, I think lots of people at this stage of Kubernetes can probably see themselves as somewhere in the middle, maybe weighted towards one. But that's not the case for everyone, and it never will be. DevOps isn't about splurging these things together. It's about working together better and playing to people's strengths and team strengths and organizational strengths. You might be building something new versus running something. There's a definite difference in your priorities and what you care about. I think Kubernetes can play to both of those, but being conscious that they are different is important. And lots more. I play on team size, but maybe you're doing something that's highly regulated. It's very tightly constrained by compliance regimes. Multi-tenancy versus not. The size of your infrastructure, not just the size of your organization. The skills and experience of your team. One of the things, again, in sort of early adopter communities and tooling around them that tends to play out is that the tooling is by people for themselves and for the people around them. Not everyone will be as skilled as you are, as experienced as you are, and I'll come on to some of those bits and pieces later. I'll take a dig at a bunch of stuff, hopefully through this, in sort of real talk. There is a page on the Kubernetes docs that I think should definitely have its title changed. It just says Kubernetes user interface, and it goes on to describe the UI application. What I want to get across is that, like, a GUI, a browser-based GUI, one single browser-based GUI is not the Kubernetes user interface. kubectl is a user interface. I even started with that before Kelsey started with that rather than YAML. But YAML is also a user interface, or rather that wire format. People are interacting with it. People are using it. often on a sort of day-to-day basis if people are interacting with Kubernetes. The new dashboard, which is really sparkly, and I'll show a bit of that later, is a user interface. I think this is where people often think, especially actually technical people think user interface, they think GUI, they think browser-based GUI now. But all of these things are places where users interact with Kubernetes. At least at this point in the sort of cycle, like with sort of the early adopters in this audience, the API itself is a user interface. Yes, you're not going to be directly, hopefully, splurging things into that via curl or whatnot, but it's still a user interface. It's still something that bleeds through in a few places. Client libraries will increasingly become a user interface as people start interacting with. Like Kubernetes is built around those primitives. It's built around that API. It's done that for a reason, so you can build things on top of it. And it's this audience that will probably build those things, whether you're already working on existing projects like Deus or OpenShift, or you're running those things and want to do something that's domain specific. The client libraries become the user interface too. And this is a good thing. Like, there will be more user interfaces to Kubernetes next year than there are today. And that's a good thing. That's not about overcomplicating things or having many different ways of doing the same thing. It's about that there are different contexts, and different interfaces are useful in different contexts. And some of that comes down to just different people might use different interfaces to achieve different tasks. Again, all those different things about the reason you might be doing something, what you're trying to do, your level of experience and exposure to Kubernetes, the amount you care about the details. So, where does that leave Kubernetes right now, today, without the sort of out-of-the-box experience? So, kubectl, loads of great demos in the keynote, so I do get away with assuming a bunch of stuff. But ultimately, kubectl provides, I think, like a universal interface for actions on a Kubernetes cluster. It is there'll be lots of tools that build on top of kubectl, and we'll see some of those later. But it is, I think, a great starting point. It's all I think I tweeted yesterday and then threw it in. It's like kubectl has so many nice touches and keeps getting better. The one I was I had a need yesterday, and suddenly kubectl proxy is there, and I'm like, someone thought of this. It's already well designed. YAML, I think, is the other one. I mean, I think for most people, if they're if you sort of grab a Kubernetes cluster or you install a Kubernetes cluster, you've got kubectl, and you'll create a YAML file, or you'll download a YAML file from one of the examples. YAML looks like this. People will not be hugely surprised. And this is where people are using YAML to describe the desired state. Whether that's the desired state of a pod because you're doing something really trivial, or a replication controller, or the new deployment manager, you're describing the desired state in a data format. I'll come on to sort of some of the bits pieces why, but realistically, that's the wire format. It is a user interface, but actually it's also a computer interface, and I'll talk a little bit by why that's good and bad. YAML is declarative, and by declarative we mean we're describing the state that we want, not how it gets there. How it gets there is the job of the schedule. It's the job of Kubernetes. That's the magic. That's the thing that is actually hard to do if you try and describe all the steps, because you need to know everything about the state of a system in order to describe the steps to get there. How do I get across to the other end of the room? Describe that in terms of steps, and it depends where you are in the room and what's in your way. And that turns out to be more complicated than just simply saying, I want to be at the other end of the room. Sort it out. So Kubernetes takes that declarative model. It's the interface it provides to you is not about the step to the other side of the room. It's about, tell me what you want and I will sort it out. That's a good thing. The YAML format describes that because that is the interface that's provided as part of the API. But I'd like to argue that when it comes to the end user, when it comes to you interacting with Kubernetes, code plus data, because that YAML file is just data. Code plus data has advantages over just data alone. And it's not just me that thinks this. This is from the Borg, Omega, and Kubernetes paper that just came out in ACMQ. The language to represent the data should be a simple data-only format, such as JSON or YAML, and programmatic modification of this data should be done in a real programming language. So the wire format, the description of the data in Kubernetes, is exactly the first bit. What I want to get at is, what about the second bit? What will that look like, and what can we do there? I think some of the reasons for wanting to use something other than just raw data are avoiding repetition, combining external inputs, like getting to correctness and sort of more so than just, is it YAML, yes or no? Like, is it valid YAML doesn't tell you anything other than like the validity of the data. You can maybe do some sort of schema-based stuff based on the API. That the API will reject sort of things which don't have the right keys, for example. But do you want to do that when you push it in or beforehand? What about writing tests that are specific to your usage? If you were writing code, you'd write unit tests. What do unit tests mean in the context of data? Creating higher level of abstractions. Not everyone is going to want to interact with Kubernetes at the lowest possible level. Not everyone is going to be, everyone who's using Kubernetes to run their applications is going to be a Kubernetes expert, or should need to be. In organizations, you can create business-specific abstractions. That's what you would do in code, not in raw data. So why are people who isn't just sort of handwriting their YAML files when it comes to describing their things in Kubernetes? Who's not? That is the 3 hands, like 4 hands and a bit, 3.5 hands. Like, I think that my point being that I think in a year's time, hopefully there's way more hands. Hopefully the 3.5 people put their hands up are talking about what they've done before then and ship some code, because I would like to see it. I'll show you mine if you show you yours, etc. There are some other reasons than the sort of the slightly abstract, slightly moving things into code about the current tooling. Some of this is criticism of the tooling as is. Some of these things are getting better, but I still think there'll always be rough edges. So, for example, in Kelsey talked about, and I've hammered on, the utility and the power of using declarative, like being declarative in terms of how we interact with Kubernetes. But actually, a bunch of the kubectl commands are not. They sort of break through that fourth wall. The kubectl patch, as an example, allows you to change something about the model you submitted, but now the YAML file is wrong. The YAML file you have is not representative of the state. It's representative of the state when it was submitted, and you've changed it. So suddenly, you now need 2 change control processes. One for your model, one for the reality. And those things are now not the same, and good luck in keeping the mental model you have of the system in check. Apply is awesome. However, apply invariably requires the full serialization at the moment. I think this will probably go away if it hasn't already in 1.2, in 1.3. But what that means is that you require, when you can't just take the YAML file you have and submit it twice. You have to submit it, then take the data that Kubernetes generated, then submit it again. So we've all seen the sort of familiar pod definitions, familiar formats. And there, what happens if you run that twice with apply? The answer is it doesn't really work. The issue there is that it requires all of the state that's already been created, a lot of the metadata that's in there. The other thing that crops up with non-trivial examples, obviously that's a trivial example. If you have a larger one, is like, how many times do you end up repeating the same labels? I don't know if this is just me and my usage of Kubernetes, but like my answer was a lot. If you go through the sort of the guestbook example, check the number of times the labels are reused, because labels are fundamental to Kubernetes and how it ties things together. And you're tying them together, so you're obviously using them in multiple places. You end up repeating things a lot. Because it's data, that's fine. But actually, as a user interface, repetition leads to error. Also, it's boring. Which is probably why it leads to error, because boring things are boring. This isn't a criticism of kubectl. I think kubectl is fantastic. I think it is, as the first entry point and de facto user interface for a whole bunch of activities in Kubernetes, it's great. What I'm arguing that is, actually, it's quite low level in some cases. And that where we'll be as we bring more people into Kubernetes is we'll have higher level user interfaces as well. And if you don't believe me, and I did not add this after it was mentioned in the State of the Union, that is from the official documentation about how to update stuff. Anything that requires piping to sed, then piping to itself, is a useful, Unix-like, but also low-level user interface. So what might high-level user interfaces look like? So I'm talking about some Puppet stuff. This isn't. I'm in engineering rather than sales. I think it's a useful indicative example, but I do want to stress that other programming languages exist, and it turns out that I've built a tool, and I'm talking about it. If other people have built tools, they should totally talk about them as well, because I think there'll be similarities and differences, and it'll be sort of interesting. And for those that don't know, Puppet it's a declarative programming language with basically an idempotent runtime model. So it's similar to Kubernetes. You're describing the end state, but you're doing so in a programming language, not just in a data format. But Puppet also has a runtime. It's not just, I'd say, it's not just data. It's a programming language. It has a runtime. The runtime is designed for idempotence. So basically, by that we mean we can run multiple times. We can keep running the same thing over and over again, and we will converge towards the desired state if needs be. But also, we can do that from any point. So we'll see some examples. If people haven't seen Puppet before, check it out. It's often used for more host-level management, but there's all sorts of other stuff it can do. So the idea is you describe what you want, and I say converge from any state. So that's pretty much the same pod described in the Puppet DSL rather than in YAML. I've formatted it slightly differently, but broadly speaking, it's the same. If you know the pod format, you sort of go like, oh, well, wait a minute, there's a metadata and namespaces, there's a spec and container. The indentation is the same, and there's some additional syntax. But Squinting, it's the same thing. It's the same data structure. One of the things I haven't done, but I'm planning on doing, is basically doing conversion between the two backwards and forwards. The nice thing is that the structure of the Kubernetes API wire format lends itself to that because it's data, which I think is, again, why it's not a perfect user interface. So that means you can then just, instead of running kubectl, you can use Puppet to apply that. I'll show some demos which make more sense. But one of those is the ability to run that multiple times. The nice thing there is you can have that constantly running and know that it's still in the state that you expect it to be. Configuration drift is a real problem in all sort of configured systems. Just simply setting something up, walking away, and assuming it's still in the same state turns out to be a dangerous sort of bet to make in any sort of non-trivial organization. The other answer is sort of long change control processes and a board, and only one person is allowed to press the button. I prefer code to that sort of process. Puppet Resource gives you the ability to query the state of resources within Puppet. You can do this using Kubernetes without having described any of this in Puppet. And this is one of the properties of not just this, but I think a number of the other tools I'm going to talk about as well, and hopefully some of the tools people have been writing, is it's not an attempt to replace, but to provide an additional interface whereby you can use both at the same time. Whether that's the same person or different people for different purposes comes back to that. There are different contexts at the same time. So again, so saying like there are other ways of doing this. I happen to work at a tool vendor, and I built a tool in this, which I'll quickly demo because hopefully it will make more sense. So, oh, I need to mirror my screen apparently. 1 second. Is that big enough or bigger? Make it slightly bigger. Next, right to go. So, what should we start with? So, I've got a bunch of, well, so that's the, oh, and I've got that open somewhere else. There we go. Ah, yeah, that'll do. So, here I've just got side-by-side like the YAML file for the entire guestbook example condensed into one. On the other side, I've got exactly the same thing converted to Puppet. It's broadly speaking the same length. This isn't an attempt to make something that's massively smaller, but I'll show you. Like this is just sort of basically a line-by-line sort of transposition. You get the idea. There are Kubernetes services described, ready to master. If you're familiar with YAML file format, you'll sort of spot the familiarities. That isn't enough value. Like doing that doesn't really prove anything, but it's sort of like that's the low-level primitive. I'll show you why that's useful to have in a programming language in a moment. So, so I've got a Kubernetes cluster running. I think it's I've got a 3-node Kubernetes cluster up and running. I'm accessing. I will run the Puppet code that I showed you in a moment ago. So all this is doing is, I didn't say, Puppet's just a programming language. The runtime is converting that into API calls to the API. And Puppet ran through and created a bunch of stuff. So obviously a load of pods started up. But if we were to look, we've got a bunch of services. We've got the guestbook application running. But what I can also do is just apply that again, and in theory, nothing should happen. Because ultimately, it's checking the existing state. It's saying, well, these things exist and are configured the same, therefore it should just work. So, jumping around a little bit. But we can also change the desired state. So what if we wanted 2 replicas of that? So again, at this point we've got a model that we can change, that we can strongly version, we can have change around it. So all that's happened there is, well, most things didn't change, and the spec changed between a bunch of stuff. So we're getting a lot of logging output. It's not particularly pleasant. It would be nicer to be a bit more filtered, but you get the idea. So you can run that all the time. We can change the model. We can have that through like a solid change control process. In our version control system, it's just code. We can do that. As I said, at that point, that's not that interesting. I've taken one like sort of data format, if you like, and I've transposed it into another data format, and I've now got a different command to run it. That's sort of what you can do with kubectl and YAML files. The point is I've taken it into a programming language, so we can do a lot more interesting stuff. So I haven't got handy here, but we could write unit tests for that. So Puppet has built-in unit testing tools. There are linting tools. There are other sort of testing tool framework stuff that isn't really there otherwise. More interesting is the ability to have the abstractions. So what about that as an example for the guestbook instead? So it's sort of the examples there are sort of 176 lines of YAML, and it's 140 of Puppet. The formatting is roughly the same, like bit different. Puppet's not shorter. However, that is definitely shorter. It's also much more specific. It's much more high level. It bleeds through a little bit when it comes to the Kubernetes stuff, but that's my choice. I've built an abstraction on top of the guestbook. I could have just made a one-liner, but that turns out not to be a great demo because people go like, "Well, you've hidden everything." That could be, but a file, and someone just says include guestbook. Job done. What I've done is I've only exposed the things that I care about changing, and I've tried to only expose things once. So I mentioned the sort of the repetition of the tags. Well, one of the things that crops up a lot in Kubernetes is that controllers and services tend to go side by side. You tend to have where you have one, you often have the other. I came up with an abstraction that I called it a controller service pair to make it clear to this audience. But that might be something more business specific. That like, it's a service, it's the thing, it's not bleeding through the implementation. So I've created abstractions, and I can run that in the same way, and I can test that in the same way. And again, like obviously I work for Puppet. I like Puppet. I like it as a language. But if you don't, map this to your language of choice. Map this to Java. Don't map this to JavaScript, please. I think Prolog would be great. Not even joking. Prolog's a declarative language. Prolog as a way of describing this stuff would be great. Prolog maybe not great. I'd really like to see a Lisp example. I think Lisp, given its sort of strength of sort of like just data munging, would actually be a really interesting model for some of this stuff. Like OCaml with like having functional and types would make sense. Does OO? I don't know. I'm not too bothered. Like I like my programming languages a bit more esoteric. So. That's one demo. You could do it with other things. If you want to find out more, there's a bunch of information on the Kubernetes blog, as well as a bunch of sort of examples in the repo. It's all open source. You can play around with it. There's a lot. The guestbook example is worked through in a series of blog posts on the Puppet Labs blog. But it's not actually all about declarative interfaces. I think declarative tends to be the best way of. It tends to be quite an operator-focused mentality. It tends to be about managing state over time. It tends to be about keeping things running. One of the things that's definitely true, though, is that declarative takes a mental leap and tends to be difficult for developers to get sort of their head around. Imperative, I want to do something now, is much more familiar. Deis is a great example of this, and again, coming back to different contexts on top of the same primitives. For those that don't know, go see the Deis people outside. Is an open source PaaS built on top of Kubernetes that I think has some really interesting properties. And part of that is a CLI that you can interact with, very much similar to Heroku. It's Heroku inspired. It's very much do this now based. So I want to log in. I want to create an application. It uses Git as the mechanism for change for a bunch of this stuff. So you switch to a different tool, but one that's familiar to that audience. You set configuration by prodding it in, not by declaring how you want the configuration to be. You scale by telling it, kubectl has this. Again, I think it's the wrong abstraction for kubectl. It's not at all for Deis. I think that's where some of those things should live. Replication controllers, services, pods are implementation details. Kubernetes is there. It's powering this in Deis version 2. But Kubernetes itself is an implementation detail from the point of view of the end user, from the point of view of the developer that's pushing something. Like, the fact it's Kubernetes isn't important. I think what's interesting there is that Kubernetes is not an implementation detail from the point of view of the administrator. If I'm running that cluster, I can care. I probably want to care. I should care that it's Kubernetes. I can understand the constraints, the scaling mechanisms, the underlying commands. At the same time as the people deploying applications don't have to. It's not that they might not want to. It's not that they can't. It's that they don't have to. And I think that's an interesting property, and like the reason why different interfaces for in different contexts can make sense. Because there are massive advantages to familiarity when encouraging people to use new things. If people are familiar with Heroku, people are familiar with Deis. Yes, there are subtle differences down like with some of the commands and how you're running it, and versus a pure software as a service thing versus something running on your own kit. But you probably discover those only once you've gone like, wow, I just launched an application in a few minutes. That's powerful. I do want to pick up on the pros and cons of that. There are actually, like, everyone in this room will go like, what? Git is easy to use. Everyone uses Git. What I can tell you is in anyone working with sort of larger enterprise organizations, then maybe not using Git. Where they are, it's often a struggle. Git is impenetrable madness at the same time as being incredibly powerful. We've just all got Stockholm Syndrome, and it's worth remembering that. So, coming on to the end bit, and the sort of two run-through examples there are sort of high-level user interfaces built on top of Kubernetes that would totally interoperate. I just didn't have quite enough time for another demo. There is an ecosystem building. I picked, like, loads of these people turned up outside and are outside. You should totally talk to them. There are others as well. The power, I think, in Kubernetes isn't, like, in comparison to some of the other tools that are out there, is in the ecosystem. It's going to be in choice over there is one way to do it. But there are some things that I think it would be useful if we share, if we bring together, if where there are one. So if people haven't seen, Helm is basically a look at what a package manager for Kubernetes might look like. Again, from the Deis folks, they've probably got some demos out there. But the general gist is, again, there's a CLI tool at the moment. It wraps kubectl, but basically allows you to download some packages, basically YAML files from a central repository. It's another user interface. It's a really interesting one, but also it has charts. So charts is a repository of these shared YAML files. Given this is a low-level primitive, Helm is built on top of this, but anything could be built on top of this if we share them. Also, contributing to this gets everyone that content, irrespective of the tool. Helm gets that, but if I build a tool on top of this, I get that too. So there's sort of like feedback cycles there for an ecosystem that are useful. One of the things that does fall out of that is the YAML format for the metadata. If anyone's familiar with package formats, they all have some metadata. That's what makes packaging cool. But we need to agree on that collaboratively together as a community if it's going to be useful outside individual tools. So is charts.yaml correct? Don't know. It works for Helm. What would it take for, not necessarily to make it, but make something? What would it look like for a general purpose packaging format metadata for things? And for people familiar with like a lot of the history here, like it's what's the Kubernetes equivalent to NPM? So Midas, package manager at Google, that is very rarely talked about, but there's this paper, so I don't feel I'm breaking any confidence by talking about it. But ask the Google people about NPM. The importance of sharing metadata to building that community, I think, is important. If we're going to have a package format, if we're going to have a package repository, which I think is useful, we need to agree and share the metadata and get it right, because changing that later is hard. Metadata needs to be a first-class part of this user interface. So I'll fly through some of this because I've only got a few minutes left. But a lot of this was covered in the keynote as well. So if the API is the point of interoperability, how can it change if we're building all these tools on top of it? The nice thing is Kubernetes uses Swagger under the hood. That's now part of the Open API initiative. Swagger, for those that don't know, is basically a format for describing APIs. The format for the API specs is about 14,000 lines of JSON. Do not read this by hand. This is for machines. But if you're building tools, don't build a client library by reading the API documentation. Auto-generate everything. The Puppet module is 10,000 lines of Ruby, 9,600 of which are auto-generated by like a very small script. Talked about the Cloud Native Computing Foundation. Standards matter. Standards mean going slow in the right places, but so we can go fast everywhere else. And I think that's the trick to play with the Cloud Native Foundation, Cloud Native Software Foundation. That it is about standards. It is about moving something slower. But I think that will allow user interfaces in particular to be above that and move quickly outside that sort of standardization process. So, coming to a conclusion, because otherwise Daniel will get cross. It is about platforms. It's about sharing and building an ecosystem. I think we can do that when it comes to user interfaces in particular, but because of the interoperability of a stable set of APIs. The Kubernetes APIs are excellent. They are well done. They are well documented. They have the core primitives, and they have a mechanism for evolving them. I think that's a massive win for a project that's actually quite young. We can expose higher-level interfaces without limiting access to lower-level ones. If you're building tools on top of Kubernetes, whether they're things like this or whether they're things like Deis or OpenShift, don't hide from everyone the fact it's Kubernetes. OpenShift does a really good job here of actually exposing all the way through for their API the Kubernetes API if you want to consume it. Deis again simply says we deal this bit, but actually if you're administering Kubernetes, you totally can do. Stick with that pattern. Don't try and sort of embrace and extend, and we end up with a stronger community. Because what I really want, what I think we can get with Kubernetes, is we can allow for different use cases and different life cycles on the same infrastructure. That has historically been incredibly difficult to do. Having separate infrastructure with separate software and separate software stacks and separate management overhead and separate monitoring and separate everything in order to facilitate different types of users and different life cycles and different speeds of adoption and all the rest of it. If we get a level playing field with Kubernetes, if we get a good ecosystem and a stable platform, I think we can actually have fundamentally different things happening on the same kit, same infrastructure. And with that, hopefully I've convinced a few people. And I'm done.
Thank you very much, Gareth. Hello. Awesome talk.